Okay, let's start today. So last week we were discussing about the programming one. Last week we were discussing about programming one, and then actually under that we have discussed about the blocks or the functions. And I just want to tell you some more things related to these blocks of functions. And before that, I would like to tell you something. So actually, I want to tell you how easy the programming language that you are using. So this programming language is by MIT, right? This MIT is basically Massachusetts Institute of Technology. It is world's third ranked university, right? University rank, you can check the Webometrics university ranking, Webometrics world university ranking, and then when you see the university list, so the number one is okay, here you can see number one is Harvard University, number two is Stanford, and number three is this Massachusetts Institute of Technology, and that is number. It is even before Oxford, Michigan, etc. And then you can see it is number 3 university in the world. They have developed this stretch programming, but earlier days programming was not easy, right? Because in programming, initially it used some other language, not this stretch or not Java, not Python. Can anybody tell what is the language used by programmers in the first stage of programming? Initial stage of programming. What was the language used by the programmers?
Algorithm.
No, it's not. No. Algorithms, today also we are using algorithms, right? So I'm asking the very first format of the programming language used by the developers or engineers, or the first generation language is, yes, first generation programming language, the very first version of programming language. There's a name. What is that? What was that? Okay, tell me how you can turn on a bulb, how you can turn off a bulb in your home. I hope you all know it. Rehansa, yes. How you can turn on and turn off a bulb?
Using the switch?
Using a switch, yes, exactly. Using a switch, you can turn on and turn off a bulb. Right? So what is the programming language? That it's not a programming language, but what is the way that you are using? It's electricity, right? You're using current. That can be represented by using 1 and 0. So if on status of the bulb can be represented using 1, off status of the bulb can be represented using 0. When you turn on the switch, the bulb will turn on. When you turn off the switch, the bulb will turn off. Turn off. Turn on the switch, the bulb will turn on. Turn off the switch, then the bulb will turn off. So that is very simple format. So this is called machine way of telling something, or called the machine language. But for the computers, it is not just 1 0. It is complex. It is many ones and many zeros. It has many ones and many zeros, as computer screen is consist of a lot of bulbs. So you can see how many bulbs are there in my screen. So when I go to display, you can see the number of bulbs. It is 1440 into 900. Very large number of bulbs. And also, these are actually pixels. These pixels are also composed with 3 bulbs. Pixel. So let's see, RGB bulbs. If you zoom it and see in computer screen, if you use a microscope, you can zoom computer screen and see this. Can you see? Each pixel will have 3 bulbs, that is red bulb, green bulb, and blue bulb. Each of these, you can see this now. Each of these pixels will have, like you can see, RGB bulb, red, green, blue. The bulbs are red, green, blue. These are the 3 bulbs. Actually, you can see this is mouse pointer. mouse pointer, the black color mouse pointer is basically created by turning off these bulbs. When you move the mouse from one place to another place, these bulbs will turn off. So how many bulbs in total in my screen? Can anybody tell how many bulbs will be there in my screen as a total? So currently you can see it has like 1440 and 900 pixels. A pixel is composed with 3 bulbs. You can see red, green, blue here. A pixel is composed with 3 bulbs, red, green, blue. Can you tell me how many bulbs are there in my screen? Altogether, how many bulbs are there in my screen? Count and tell me. How many bulbs are there in my screen? This is easy question. You can tell me the calculation. If you cannot tell the number, tell me the calculation, how to calculate that. Yes. Quickly, don't take much time. I have just done single medium class. They have responded very quickly. Yes, how many bulbs in total? Okay. Rehan?
888,000 bulbs.
No. Because one pixel will have 3 bulbs. One pixel will have 3 bulbs. Therefore, like 1440 pixels means there are totally 4,320 bulbs. 900 pixels means there are 900, 900, 900 RGB red 900, green 900, blue 900 altogether. That is 2,700 bulbs, and altogether there will be like 116,000. 116 lakhs or 11.6 million. 11.6 million bulbs. Understood? Because RGB 3 things, right? RGB 3 එකතු කරලා තමයි pixel එක මම highlight කරලා පෙන්නන්නේ bulb 3ක් තියෙනවා එක pixel එකේ. දැන් මෙතන pixel 1440යි. ඉතින් 1440 bulbs තියෙනවා 4000. 900 උඩ අතට තියෙනවා 900ක් තියෙනවා කියන්නේ ඒ 3 තියෙනවා. එතකොට pixel 900ක් කියලා කියන්නේ ආසන්න වශයෙන් එතන දැන් RGB 3ෙන් හැදෙන්නේ RGB 3ෙන් මේ පැත්තට 900ක් කියලා 900 නම් අඩුයි. So anyway 900 pixels මේ අතටනේ තියෙන්නේ මේ තුන. This is this direction නේ. එතන මේ අතට 1440යි කියන්නේ එක තුන් ගුණයක් තියෙනවා. The calculation like power 1440 into 3 උසාතට මෙහෙමනේ තියෙන ඒක තමයි 900ම තමයි. You have to multiply with 900 and then 1440 into 3 into 900 and you will have like okay sorry yes your calculation is correct. There will be is this amount of bulbs, correct, because horizontally it's not 3 yeah, this amount of bulbs, correct, because may pattern තුනක් නැහැ. This side it is only one. RGB is only this side, correct. Okay, that much of bulbs, right? Then you are asked to then you are asked to light up these bulbs and show. You are asked to light up these bulbs and show a picture. Here, this is small one. So let's say you are asked to turn control these bulbs. There are like 38 million bulbs. You are given 38 million switches, and now you have to create this image like this. Okay. Face of a girl. Okay, you are about to create this kind of image in your screen. You are about to create this kind of image in your screen using these bulbs. Using these bulbs, you are going to create this image in your screen. How long will it take? Yes, how long will it take to create this image in your computer screen using these 38 million bulbs? Right? Using these 38 million bulbs, how long will it take? Yes, any idea? This is the image, and let me zoom the image. You can see 1 pixel is this. This is just 1 pixel. There are a lot of pixels like this. And you are to create these pixels using RGB bulbs. Okay, how many days or how many, like, is it easy? Lazy the image එක පෙන්වන්න කිව්වොත් අර switch ගාන පාවිච්චි කරලා මේ bulbs ටික පාවිච්චි කරලා you have to turn off and turn on bulbs and show this. This is the machine language. Initially මේ මුල් කාලේ computers වල switch ගොඩාක් තිබ්බ මේවා connect කරන්න. මේ තියෙන්නේ first generation computers. Let's say this is called let me show you ENIAC. and මේ තියෙන ENIAC කියන computer එක. දැන් මේකේ switches ගොඩාක් තියෙනවා. මේ switches තියෙන්නේ හරි මේ switches තියෙන්නේ මේ වගේ bulbs on කරලා. There are a lot of switches. So later these switches vacuum tubes ඊට පස්සේ ඒවා transistors උනා ඒවා IC උනා දැන් තමයි මේ පුංචි වෙලා තියෙන්නේ. But initially these are like this. Lot of switches and wiring. දැන් මේවා පාවිච්චි කරලා අර screen එකේ හදන්න. Was it a easy job?
So everything manually, sir?
Yes, manual. And we will have some automation, but very small amount of automation. මේ තියෙන්නේ කට්ටි මේ switch දදා මේ කරන්නේ ඒක තමයි. What do you think? Programming, will it be easy? මෙහෙම තමයි programming ඉස්සලම කරේ. මේ තියෙන්නේ switch boards. Lazy වෙන්නේ නැතිද? In order to display a letter, in order to display a number, in order to display a picture, a lot of effort, right? හැබැයි දැන් එහෙමද? නෑ ඊට පස්සේ ආව high level languages. Now also දැනටත් මෙහෙම තමයි screen එකේ පින්තූර හැදෙන්නේ. Still it is same. But the thing is, now we have sophisticated ways of doing that. That is very fast now. It is automated because the translation will happen in the middle. We have to code, අපි code එක ලියනවා. අතරමැද translation එකක් වෙනවා. ඒක වේගින් වෙනවා. We are writing codes using Java, Python, C, C++, C#, .NET. These languages are high level, easy, human readable language. There are 1-0 වලින් අමාරුවෙන් on off signal වලින් ලියන්න ඕන නැහැ. Switch වලින් on කර කර hardware වල වැඩ කරන්න ඕන නැහැ. When we write that, automatically it will be converted to hardware language. Hardware language එක තමයි machine language. අපි program එක මෙතන print කියලා ලිව්වම, let's say we are writing here print hello. එතන මේ screen එකේ display කරන්න ඕන bulb pattern එක මෙයා හදා ගන්න. So that will be displayed. This is a bulb pattern. This hello is not. දැන් ඔයා මේ දකින්න hello කිව්වට hello නෙවෙයි මෙතන තියෙන්නේ. මේ තියෙන්නේ bulb on off වෙන pattern එක. Okay. දැන් ඔයාලා මේ පින්තූරයක් දැක්කට මෙතන පින්තූරයක් නෙවෙයි තියෙන්නේ. This is not a picture. මේ පින්තූරයක් නෙවෙයි තියෙන්නේ මේ bulb on off වෙන pattern එක. හරි. එතකොට මේ තියෙන්නේ මේ image එක මේ ඔයාලට මේ structure start කරාම මේ තියෙන image එක ඔයාලට පින්තූරයක් තමයි බලනකොට පින්තූරයක් තමයි. You will look at this as a picture, but actually speaking these are pixels. මේවා dots, turn on turn off වෙන dots. These are pixels which are turn on and turn off. Turn on turn off වෙන pixels. Right? So this cat is moving. මේ පූසා දැන් අපිට move වෙනවා කියලා. Okay, ඔයාලට නම් මේක නිකන් motion එකට ගියා, move 10 steps, events, flag click, then control forever, move 10 steps, okay. Forever moving 10 steps. When you go to the corner, you can say if on edge bounce and set the style to left, right. And then when you click on the cat, it's moving and coming back. If you want to swap the legs, you can use the next costume. Now it's basically rotate, swapping the legs also. And let's put a background also. Now you have beautiful background in the behind the cat, and cat is moving. Actually speaking, this is not an image, or this is not an animation. Make a hariyata thoranaka bulb pattu වෙනවා නෙවෙනවා. Actually speaking, if you zoom and see, these are bulbs which are turning on and turning off. නිකන් හිතලා බලන්න, imagine you saw the pixels, right? Pixels දැක්කනේ ඔයාලා. RGB pixels දැක්කනේ. එතකොට මේ cat move වෙනවා කියන්නේ bulbs පත් වෙනවා නෙවෙනවනේ the screen එකේ ඇත්තටම. Colors කියන්නේ bulb combination එක. Different colors are different combination of bulbs. You can see these lights are turning on, turning off. Isn't that so? Hello, hello, hello. Can you understand what's happening behind the screen? The
Yes.
hardware part. So this is like a Vesak Toran. Vesak Toranak wage tama meka. ඔයාලට මෙහෙම පේනවා. So because it is very tiny, you cannot identify the bulbs individually, but still it is turning on, turning off bulbs. This is very complex. That is what I want to tell you. The process is very complex. The process is not simple. Process is very complex. But for you, it's very easy. ඕගොල්ලන්ට මේ process එක හරි lazy. What's the reason? Why it is easy? For you, this process is easy. Why it is that easy? Yes, because you have like MIT, this Manchester Institute of IT, they have developed interesting language called Scratch, where kids can even do the programming. No need to be electrical engineers, electronic engineers. Electrical engineers la wenna ඕන නැහැ, electronic engineers la wenna ඕන නැහැ, එතකොට computer engineers la wenna ඕන නැහැ. උන්චි ළමයින්ට programming කරන්න පුළුවන්. එතකොට Scratch කියන්නේ lazy එකක් කියන එක තමයි මම ඔය Nokia කිව්වේ. How easy Scratch is. ඉස්සර වගේ programming කරන්න තිබ්බනම් ඔයාලා මේ පන්තියේ පැත්ත පළාත එන්නේ නැහැ. ඔය switch on off කර කර programming කරන්න තිබ්බනම් it will be very very difficult. You will not come to the class even, because that is very complex calculations. But now you can see this is easy. So here this is the note, and this time you have to request the note from Miss Lakmali, right? Okay, we have learned about pre-control structures. Can you remember them? We have learned about pre-control structures. What are they?
Sequence, selection, repetition.
Yes. Sequence, selection, repetition. So if you can remember this, we have learned in our grade 6, right? You can see this enter number 1, enter number 2. These are inputs. Inputs are using parallelogram symbol. This is called flowchart. Flowchart කියලා කියන්නේ. එතන මේ inputs වලට use වෙන්නේ parallelogram, සමාන්තර ආශ්‍රිත. Outputs are also displayed using a parallelogram. Display is the output. Enter number 1, enter number 2, inputs. Total equal to number 1, number 2. What is that?
Process.
Process, exactly. Then start and stop are ellipses or these rounded rectangles. Hurry. Then the same program translated to the Scratch version, you can see sequence, means instructions are executed one after another. Very simple, in an order. It's like a waterfall coming from the top to bottom, one by one by one. That will be very, very easy. I hope you understood that. That is sequence. In the selection process, this is where the selection comes. Read the question. In selection, if marks greater than or equal to 50, then display pass, else display fail. So you are getting the mark, input mark. This is input. That after that you are evaluating. If mark is greater than or equal to 50, then marks greater than or equal to 50, then pass. Less than 50, then fail. I mean, greater than 50, not pass. Else fail. You can either be pass or fail. You cannot select both. දෙකම වෙන්න බෑ එකම වෙලාවේ. එක්ක pass එක්ක fail. Pass උත් වෙලා fail උත් වෙන්න බෑ. Either pass or fail. Cannot select both together. Right. When it is like you can see the implementation in Scratch. Corresponding implementation. You will get this note, right? Please contact Miss Lakmali. She will issue the note. because this month onward, Ms. Gavesha is not there since she's basically out for some other work, and you have to contact Ms. Lakmali to get things done. Right here, you can see marks greater than or equal to 50, then pass, otherwise fail. So you can retrieve, you can ask for this now from her. Okay, here you can see it in more complex way. If there are multiple if else's, this is also selection, but multiple if else's, multiple if else's, right? Multiple if else's. If average greater than or equal to 75, A. If not, if it is greater than or equal to 60, B. If not, if it is greater than or equal to 50, C. If not, if it is greater than or equal to 40, F. Otherwise, fail. Now multiple conditions. See? So multiple if else, multiple conditions. 70 පාට වැඩි නම් A. එහෙම නැත්නම් 60ට වැඩි නම් B. එහෙමත් නැත්නම් 50ට වැඩි නම් C. එහෙමත් නැත්නම් 40ට වැඩි නම් S. එහෙමත් නැත්නම් 40ට වැඩි නම් fail. You can see. Okay, considering that, now try for this one. Third one, this is just to like, otherwise you will feel boring if I'm continuously read that. Try this quickly. Make a try. Yes, you can share. Only Rehan sir. Just printing in odd numbers. This is very easy exercise, right? We have done this several times. Okay, this are odd number 0. Wait 1 second. Okay, print it. Odd numbers are odd name print karana evens. You are printing evens. Okay, that is odd. Okay, good. Right, okay, good. Right, how to do this? Let me show for those who are new and those who couldn't do. But remember that some of you have done that already. Okay, let's see this. I'm going to start when flag click. I'm going to start when flag click, and I'm going to start with number 1 that I can do using a variable. I can say num is my variable name, num. Here, make a variable name is num, make a variable, then num is the variable name. And initially set the num to 1. I'm going to start with number 1. And then I'm going to repeat this for 5 times. And what I'm going to print is from the looks, I'm going to print, say, instead of hello, this number I'm going to tell. And after telling that, I'm going to change it by 2. The first number will be 1. After that, I'm changing it by 2. So as a result, you can see it's printing 1, 3, 5, 7, 9. These are odd numbers. Similarly, okay, I will put this to another event. When I press A key, I need odd numbers. Similar to that, when I press B key, I need even numbers. When I press B key, start with the 2, start with number 2. So when I press B, it is even numbers. 2, 4, 6, 8, 10. These are even numbers. Then I need square numbers too. Square numbers, you know, it is when I press C, I need square numbers. The square numbers, first 10 square numbers I can generate by increasing 1 by 1. But you know the way square numbers are generated. 1 into 1, 2 into 2, 3 into 3, 4 into 4, likewise generated. And I'm taking this and I'm putting num here. And again, I'm putting num here, then num into num. So first one will be 1 into 1, the second one will be 2 into 2. So when I press C, see 1 into 1 is 1, 2 into 2 is 4, 3 into 3 is 9, 4 into 4 is 16, 5 into 5, 25, 6 into 6 is 36, and 7 into 7, 49, 8 into 8 is 64, 9 into 9, 81, and 10 into 10 is 100. So it's printing that values, and then I need to print triangular numbers also. I hope you can remember the patterns, how triangular numbers are generated. So let me show that using very simple star in the screen. Here you have 1 star. 1 plus 2 is 3 stars. 1 plus 2 plus 3 is the next triangular, which is 6. That plus 4 is 10 is the next. That plus 5 is 15 is the next. Likewise, this is how the triangular numbers are generated. So 0, 0 plus 1, that plus 2, that plus 3, that plus 4, that plus 5, that plus 6, that plus 7, that plus 8, that plus 9. This is how the triangular numbers are generated. Therefore, I need another variable. I'm just making a new variable. Sorry, I'm just erasing this out again. Making a new, erasing it in the mouse pointer. Creating a new variable. This time the variable is triangular number Tn. Initially, I'm setting the Tn to 0. Set triangular number to 0. Then number to 1 and increasing number 1 by 1. That need to be done. Increasing the number 1 by 1 because that need to be done. And after that, what I'm going to do is, okay, after that, I'm printing, instead of num into num, I'm just printing the triangular number Tn. And the next triangular number can be generated by, how the triangular number can be generated. First triangular number can be generated by not setting actually. Before setting, I think we have to change it. How the existing triangular number, you need to change the existing triangular number by this number. The first time num is 1. So Tn will be 1. Then the num will 2. Then Tn will be 1, will be changing by 2. That is 3. Now Tn is 3. Next time Tn will be changed by num. Num is now 3. 3 changed by 3 will be, likewise, it's always changing by the num. So when I press letter D, see, I'm generating the triangular number. D is 1, 1 plus 2, 3, that plus 3, 3, 6, that plus 4, 10, that plus 5, 15, that plus 6, 21, plus 7, 28, plus 8, 36, plus 9, 45, plus 10, 55, plus 11, 66, likewise moving up. Okay, please do all 4 now. Those who have done, it's okay. Others, please quickly do this and understand how this happens. I will give you 5 minutes. I'm taking a new file. And with this new file, I'm going to develop the game now. Instead of cat, let me select some other sprite. Let's select. Okay, let's select penguin. And there are several costumes. I'm going to use the costume 2C and 2D. 2C, 2D. Okay, 2C, 2D together. Okay. Then what I'm going to do is I'm going to reduce the size of penguin to 40. A small one. Let's change the background. You can select anything, but I'm going to select. Okay, I'm again selecting the blue sky. Now I need to move the penguin while I'm moving the mouse pointer. To do that, I'm going to click on the event. When I click the flag, I need to change the X position of this penguin. Set X, and I'm going to sense the mouse and take X. So when I'm moving my mouse, the penguin is also moving the same direction as my mouse pointer. Here. Actually, this need to be done forever. Okay, now you can see it's moving with this. And when I go to the corner, I just need to sap the it to other side, and let's go to the motion and point. I just want if on the edge bounce, and also need to rotation style need to be set to left, right. Why? Because otherwise the penguin will upside down, right? In order to stop that, I need to put the left, right style rotation. Then you can see when I move, it's not rotating the other way. Now you can see that part is done, and I need to put something down that penguin can catch. That is the game. So let's introduce another sprite. This is very simple code for the penguin just to move with the mouse to both direction. Okay, you can take a screenshot and try it. Let's put some thing coming from the sky. Penguin, are they interested in apples? You can decide. Okay, I'll put apple. Anything that you like, you can put. Okay, this penguin is interested in apples. I just need to put the apple in the sky. Actually, I can put it 180, means the topmost position. And let's make it smaller, 20. Now it is a small apple, and it's going to fall from the sky to down. And to do that, I'm going to use, when I click the flag, just need to fall it down. Let's repeat it, say 30 times, just to move down it downwards. Motion need to be done in the direction of 180 degrees this time, because downwards, and just need to move 10 steps. Let's see. When I click the flag, okay, not enough. Not enough. So let's set the position, starting position to 180, go to 11, 180. You can see it's falling from the sky, but not enough. So let's increase it to 34. Okay, fall into the ground. Good. I just need to fall it from a random position, not from the same position, from a random position. Therefore, I will go to operation, and here I just put the pick a random. The X need to be a random value. Let's say X is between minus 240 to plus 240. That means X can be here to here, any value. Y is 180. That means falling from somewhere. You can see falling from somewhere, not from the exact place. Time to time is different because it's a random. Random tanakin, time to time, initially I need to hide this apple. Initially I need to hide this apple. When it is falling down, I need to show it. From the looks I'm showing when it is falling down only. And after rounding, I can hide it again. Fall down and hide it. Fall down, hiding. Fall down, hiding. Maybe after some time I can hide, right? I can keep it after rounding. Round උනාට පස්සේ ටික වෙලාවක් තියලා hide කරමු. එකපාර නරක් වෙන්නේ. Maybe wait 3 seconds and hide. Falling down, wait 3 seconds, 1, 2, 3, and will be hidden. Okay, now it's falling. Okay, falling down after 3 seconds, it's hidden. Okay, I need to put few apples, not just one apple. I just need to put multiple apples. Therefore, I will put 10 apples or 20 apples. Let's say I need 20 apples to fall down. Repeat 20 times. How to copy? To copy, I can use create a clone of myself, but not suddenly, after certain time. After waiting a random time, not suddenly. After waiting 1 second on it, 1 second is random time. Again, I can use the sensing, operations. From that, I can pick a random. Random time එකක් ඉඳලා තමයි clone එක හදන්න. Clone එක හැදුනට පස්සේ clone එක වැටෙනවා. So after creating the clone, we can say when I create the clone, then when I start the clone, just fall down. Okay, let's press this. First one is falling down. Okay, after few seconds, another one should fall down from somewhere else. Falling down. After few seconds, another one should fall down. After few seconds, another one should fall down. So likewise, 20 apples need to fall down. Okay, that is this instructions. Okay, very quick recap. After this is happening 20 times, it will wait random amount of time, 1 to 5 seconds. තප්පර 1ත් 5ත් අතර කාලයක් ඉවසලා ඉඳලා කොපියක් හදනවා. කොපිය show වෙලා පල්ලෙහාට වැටෙනවා. ඒකත් random තැනකින් තමයි පටන් ගන්නෙ. හැබැයි ඔක්කොම අහසෙන් පටන් ගන්නෙ. random තැනකින් පටන් ගෙන තමයි වැටෙන්නේ. Next, actually, this penguin need to capture apples. And based on the number of apples that it catch, you can put marks. Marks දාන්න පුළුවන්. Apple අල්ලන ප්‍රමාණය මත තමයි marks දාන්න ඕන. Before rounding, you need to catch the apple. That part I will keep it to you. I will keep that part to you. ඔගොල්ලෝ ඒක කරන්න. I will discuss that part next day. Now for the moment, take a screenshot and start doing this now and do it by yourself. තනියෙන් කරන්න. Next day, what I'm going to teach? I'm going to teach you how to count marks. After that, I will show you how to convert this to a website. Right? After that, I will convert this to a website. Okay then. I'll stop from here. Next day, I will be discussing the remaining part. Then good night. See you all next week. Okay, bye.
Good night, sir.
Okay, bye.